Building a car requires a sequence of specialized stages. Raw materials move through cutting, assembly, painting, and testing, a strict manufacturing order that transforms raw steel into a finished vehicle. Modern software follows this exact model. High-level code enters a compiler to be processed through a digital pipeline. Looking inside the compiler reveals 6 internal departments. Each one takes the source program and moves it one step closer to the final target program. This is a coordinated system of isolated stages. Every department is responsible for exactly one aspect of the translation before passing the work forward. Phase 1 is lexical analysis. It identifies individual tokens, separating the code into its basic vocabulary. Those tokens then move to the syntax analyzer, which ensures they follow structural rules to form a valid hierarchy called a parse tree. If symbols are out of order, the parser rejects the sequence and reports a syntax error. Phase 3, semantic analysis, checks for logical meaning. It flags a mismatch if you try to store a text string inside an integer variable. Think of the sentence, "The stone is eating pizza." The grammar is perfect, but the meaning is nonsense. The semantic analyzer catches these logic-based issues. Look at this code snippet. We have a missing value after the plus sign. Based on our pipeline, which phase stops the compilation here? That was a job for syntax analysis. These first 3 phases act as a quality control firewall, ensuring code is readable, structural, and logical. Phase 4, intermediate code generation, breaks complex human logic into simple, temporary steps. Then, in Phase 5, the code optimizer finds shortcuts. It calculates the math in advance and collapses the steps down to make the final program run faster. Finally, Phase 6, code generation, performs the actual translation into machine instructions, resolving the logic into a stream of raw binary data. Every stage is monitored by the symbol table, which tracks variable data, and the error handler, which reports mistakes the moment they occur anywhere in the pipeline. This back half of the pipeline turns human intent into the most efficient instructions the hardware can execute. To manage this complexity, we divide the pipeline into 2 halves. The top 3 phases make up the front end. This domain is analytical, focusing entirely on understanding and validating the programmer's code. The bottom 3 phases form the back end. This domain is generative, focusing on building and refining the final machine-level program. To recap the flow, the scanner finds the words, the parser checks the grammar, semantics checks the meaning, ICG creates temporary code, the optimizer makes it faster, and the generator creates the machine code. This architecture provides a clear, logical framework for translation. By breaking the process into these 6 steps, a compiler turns abstract human thought into digital reality.